Okay, good morning. So today we're going to be working on solving rational equations. So this is section 9.6 in your book. Okay, I think I'm going to hop past the warm-up so I don't make these notes extra long today. And so it says to solve a rational equation, you're going to multiply each term on both sides of the equation by the LCD, so least common denominator, and then simplify and solve. And we do have to check these, okay? So some people used to call this like clearing the fraction. So a lot of you, if you came across this equation, you would be like, okay, that's super ugly, which I agree with. But if you find the common denominator and then just multiply this entire equation by that denominator, it's going to give you a very, simple equation that you've been solving for a long time to work with. So my denominators on this one are x, 2, and x. So it's the same thing we've been doing. Here's my match. There's my leftover. So my LCD is 2x. So I'm going to take this, what I like to do, sorry guys, is take the LCD and multiply it to every single piece is what I call it. So I'm going to go times 2x times 2x times 2x, okay? Now, if you have found the correct LCD, then every single denominator should cross out. So, I don't know if I can zoom in a little bit. This is kind of small typing. So there's an x on top now and an x on the bottom. The x's go away, and I'm left with 2 times 3. So that will become 6. Minus, there's a 2 on the bottom and a 2 on the top. Those go away. I'm left with 1 times x. So this is just x or 1x. And then on the other side, x on the bottom, x on the top. The x's are going to go away. 12 times 2 is 24. So see how we go from this ugly looking equation to something that you've been solving for a very long time. So negative x is 18, so that means x is going to be negative 18. Oops, sorry. All right, so to check this, we have 3 over negative 18 minus 1/2. Does that equal, that's the big question, 12 over negative 18. Now, obviously, I highly recommend a calculator for these. If you have that, then it's going to be pretty quick, I think, to punch those in. So like I have a calculator right here that does really good fractions. So I'm just going to do 3 over negative 18 minus 1/2. And I'm going to hit enter. And so that's negative 2/3. So this is negative 2/3. Does that equal 12 over negative 18? Well, yes, it does, because if you divide both of these by 6, this is negative 2/3. So this one checks. Oops, and you couldn't see any of that. I'm sorry. I have to remember to pull that over on the next one. Sorry. There we go. Okay. You have to check your answers to make sure there's no extraneous or false solutions. So even though it's kind of a pain, you've got a calculator, just use the calculator to help you check. Oh, I know why you couldn't see that, because I zoomed in. Duh. Okay. I need to go in a little bit. Oops. Okay. So on this one, my denominators are x plus 1. Don't be tricked. That denominator is a 1. And then x plus 1. So my LCD on this one is just going to be x plus 1. So I'm going to multiply this by x plus 1. I'm going to multiply that piece by x plus 1. And I'm going to multiply that piece by x plus 1. Okay, so in the first fraction, my denominator is an x plus 1. So that's going to cross out that x plus 1 on the top. And all I'm left with is 5x. And the denominator on the second one is just a 1. That doesn't cross out anything, so I'm going to have to multiply this 4 there, so 4x plus 4. And then the denominator on the last one is an x plus 1, which crosses out the x plus 1 on the top, and I just get minus 5. Again, this becomes a very simple equation to solve. 5x is equal to 4x minus 1. Subtract that over x is negative 1. And now let's check. So we have 5 times negative 1 over negative 1 plus 1 equals 4 minus 5 over negative 1 plus 1. So we get negative 5 over 0, and we run into a problem. You can't ever divide by 0 If you punch that in your calculator, I think it actually even says error or like syntax error. You cannot divide by 0. So what this tells us is this was one of those false or extraneous solutions. So that solution doesn't work. I don't have any other solution. So my final answer on this one is no solution. So that is definitely why it's important to check. Okay, the next one, this LCT is x minus 2. The next one is x plus 2 times x minus 2. Sorry, I should have lined up those x minus 2s. And then the last one is a 1. So even though I didn't write these very well, this is my match, okay? And that's my leftover. So my denominator is going to be x plus 2 times x minus 2. That's my LCD. And I have to multiply it, remember, to every single piece. And you start with your denominator. It's an x minus 2. That goes away. So does this x minus 2. But now we have to multiply x plus 2 times 3x minus 2. So there's going to be a lot of double distributing in this one. So x times 3x is 3x squared. X times negative 2 is negative 2x. 2 times 3x is plus 6x. And 2 times negative 2 is negative 4. So that's just from the very first fraction. All right, the next one, x squared minus 4 is x plus 2 times x minus 2. So this whole thing is going to cross out. Yay. So that gives me just a 6 for that part. And then the last one, the ones don't really cross out with anything. So you just double distribute back here. We get x squared minus 2x plus 2x minus 4. So I know right away this minus 2x plus 2x is going to cross out. This I'm going to have to group. So I need to move my 6 over here. I need to move my x squared over here, and I need to move my plus 4. I guess I could have combined those, but that needs to come over here as well. Okay, so I get 2x squared, negative 2x plus 6x is plus 4x, and this is going to be minus 6, I think, with all of that, equals 0. So all I did was just kind of add straight down there. All right, well, this is a quadratic with a GCF at 2, so I'm going to take that 2 out. X squared plus 2x minus 3 equals 0. So this is the x method. Can you multiply to make negative 3 and add to make positive 2? So it'd be 3 and negative 1. So we get 2 times x plus 3 times x minus 1 equals 0. So my two solutions are negative 3 and 1. So I have to check 2 answers on this one. Okay, so I'll check negative 3 first. So 3 times negative 3 minus 2 over negative 3 minus 2. Does that equal 6 over negative 3 squared minus 4 all plus 1? So this is negative 9 minus 2 is negative 11 over negative 5. So that's just going to be 11 fifths. Okay, does that equal 6 over, this is 9 minus 4 is 5 plus 1. And it does, because 6 fifths plus 1 is 11 fifths, so that one checks out. Okay, and then you got to check your 1. So since I'm kind of running out of room, I'm going to go just right up above here. So 3 times 1 minus 2 over, what was our, 1 minus 2, right? Equals 6 over 1 squared minus 4 plus 1. So this is 3 minus 2, just 1 over negative 1 equal 6 over, what is that, negative 3 plus 1. So does negative 1 equal negative 2 plus 1? Yes, it does. So both of these actually work. So negative 3 and 1 are both solutions. Okay, last little case here. You want to keep your eyes out for this, okay? Anytime there's just one fraction on each side of the equation. So in all these other ones, like one of the sides, like this one had 2 fractions on this side, 1 on that side, 2, 1. So we can't do this quick part that you can do here. But when you have 1 and 1, you can just cross multiply to solve. So these will actually be quicker. I mean, you can obviously still use the LCD, But when it's just one fraction here, one fraction bar there, you can just cross multiply. So 3 times x plus 4 equals 1 times x squared plus 4x. So we get 3x plus 12 equals x squared plus 4x. So it's a quadratic. I'm going to get it into standard form. Sorry. So this side becomes 0 equals x squared plus x minus 12. So that's the x method. Multiply to negative 12, add to positive 1. That's going to be 4 and negative 3. So 0 is x plus 4 times x minus 3. So I can either have a solution of x equals negative 4 or x equals 3. So I'm going to check the negative 4 first. 3 over negative 4 squared plus 4 times negative 4. Does that equal 1 over negative 4 plus 4? So I'm not even going to start working out this left side, because right here I see negative 4 plus 4. I see 1 over 0, which we cannot have. No, so that's out. That negative 4 doesn't work. So now I'm going to check the 3. 3 over 3 squared plus 4 times 3. Does that equal 1 over 3 plus 4? So does 3 over 9 plus 12 equals 1 over 7? Does 3 over 21 equal 1 over 7? Yes, it does. So my only solution to this one is 3.